Alright, so number 11 is complex, and we have to clear the fractions. So I'm looking at my little denominators, that's what I call them. So that 3 and the 12, and the LCD for that is 12. So I'm going to multiply the top by 12 over 1 and the bottom by 12 over 1. So for this first part, 3 goes into 12 4 times, and I'm left with 4y on top over 1, and I don't need that 1 on the bottom. And then here the 12s cancel, and I'm left with y to the 5th over 1, which is just y to the 5th on the bottom. This y takes out one of those y's, so my final answer is 4 over y to the 4th. Alright, number 12, again I have complex. My denominators are x plus 5, and x, and a 7. So I have to multiply all that stuff together to clear them. So 7 times x plus 5. So that's what I have to multiply each term by. So I have the 7x times x plus 5 times the x plus 5. And then I have the minus 3x. I'll put a 1 underneath that. And that has to be multiplied by 7x times x plus 5. And on the bottom, I had x over 7. And that has to be multiplied by 7x times x plus 5. So all of those were distributed. And now the x plus 5's cancel there. The x's cancel there, and the 7's cancel there. So what do I have left? I have 7x times x, which gives me 7x squared. Then I have 3 times 7 times x plus 5, so I'm just going to write it as negative 21x. And then negative 21 times 5. Oops, my calculator. And that gives me negative 105. On the bottom, just the 7's cancel, so I have x times x, which is x squared, times x plus 5. So I left this kind of in factored form because I want to see if I can factor the top. I know I can factor at least the 7 out of everything. So if I pull that 7 out, I have x squared minus 3x minus 105 divided by 7 is minus 15. Alright, can I do anything with that? 15 is 5 times 3, the difference is 2, so that's not factorable. So that's as far as I can go, so that one would be A. Alright, now we're into solving. So once we have an equal sign, we actually can get rid of the fractions, right? So we can get rid of the rationals. And I'm going to do the same thing though. I'm looking for the LCD and then multiplying it through. So I have a 7, and a t. So 7t is my LCD. And I have to multiply 7t by every single one of these terms. So the first one, the t gets knocked out, and I'm left with 7 times 1, which is just 7. The second one, the 7 gets knocked out, so I'm left with negative 22 times t, which is negative 22t. And then on the other side of the equal sign, the 7 gets knocked out, so I'm left with negative t. So to solve this, I just have to get t's by themselves. So I'm going to add 22t to both sides, and I get 7 equals 21t, and then divide by 21 and reduce that, so we get 1/3 is equal to t. Number 14, again it's solving an equation. So there's only one denominator, which is q, so I have to multiply every single term by that q. So here I get q squared. Here the q's cancel, so I have plus 4. And then on the other side, I have 4q. This time I have a quadratic, so I need to have it set equal to 0 so I can see if I can factor it. So when I move the 4q over, it becomes minus 4q. So we have q squared minus 4q plus 4 is equal to 0. And that factors to q minus 2 times q minus 2. Set equal to 0. And we get q is equal to 2.